Okay, welcome to my class. And then so if you go to D12 and on module 01, then you will see that I have added one version, a newer version of lecture slide 01, version 2.1, and then please download this slide. There are some extra information on this slide. Especially this slide has some information about switch, and you will see that I have added my own version. It goes by _mh by my initials. This is my own version. In my personal version, I have added some extra information that I believe will be useful for you to review. And if today we will cover lecture 3, but before that let me go quickly lecture 01 review in version 2. So that I have my copy here, not this one, 2.1, this version. And in this version we have some extra information about switch statement, and this is the pseudocode for switch. Actually, switch is more likely if, else if, else, and the else is the default one. Okay, and let us see a code in the switch case statement. All case statements go inside the switch, within the switch body, and in the switch statement, on the same line, there is the switch statement is associated with a condition, with a Boolean condition, with a logical condition. Okay. So in general, we have seen that the other logical condition for while or do while or if, we use only Boolean condition. But here the difference is that switch can take any kind of, like, other than Boolean. It can take a Boolean condition, it can take an integer, or it can take a character type or enum type, and it can take a string type. Since Java version 6 or 7, I believe, it takes string type in the condition. So here the condition is an integer value, so it will get a Fahrenheit value, whatever the Fahrenheit value is, and that will be divided by 10, an integer number, and whatever the value is in a decimal format, that will be temporarily converted into an integer number using typecasting, and that integer value will be provided here in the condition, as the condition. And if the value is 10, then it will go to this case, and if that is 9, then it will go to that case, and if it is 8, then that will go to this case, and if it is 7, then the control will go on 7, and if it is neither of this, then it will go to the default block. And for all cases, it is required to have a break statement. Break allows the control to go outside the switch. So if you do not have a break, then still it will check, it will go to the next case. And if you do not have a break here, then it will go to the next step. Okay, and at the end, actually, the default block does not require a break. Okay, so there is no requirement that you have to have these cases in order or ascending or descending order. You can put in any order if you have breaks. Okay, so this is a Java program code, and this is corresponding C# code, and in Python there is no break, no switch statement. Okay, so please go through this. This is a potential question for one of your tests. Okay. Now let me go through the next slide. Now we will start from here. We'll start here from searching algorithm. Actually, we will cover searching and searching algorithm quickly, because you know searching algorithm. Searching algorithm is easier than sorting, so I want to spend more time for sorting. Okay. So there are a lot of use of searching and sorting algorithms. So if you are good in searching and sorting algorithms, okay, then it will be easier for you to do a lot of assignments in your data structure and algorithm and other courses. Okay. So although we did not have enough time to cover a lot of sorting algorithms in your previous course 1321, but we covered bubble sort and selection sort last time, but this time we will cover insertion sorting algorithm as well as. Okay, so there are many searching and sorting algorithms. Still, computer scientists are doing research in order to improve this especially sorting algorithms, or in order to develop new sorting algorithms. Apparently, with a small set of data, you will not find the difference between these algorithms, but consider for a big data set, huge data. What will happen if you want to sort all of the first name or last name or middle name of all people in a state or in a city or in a country? That will be huge, right? So in that case, selection of an efficient algorithm is a matter. But for the program, we will discuss small demo in our class. You will not realize the difference between this version like bubble sort or selection sort or insertion sort. Okay. So you may sometimes you may be frustrated. Why do I need to learn this many sorting algorithms? Right? I could learn only one. But definitely you will need to have idea about many sorting and searching algorithms. So linear search is the most efficient and most frequently used searching algorithm. Okay. So linear search is that means it will be searching an element in a list starting from the beginning towards the end of the list, or vice versa, or reverse order, starting from the end to the top. Okay, so unless you find it, or unless you go at the end of the list. Okay, so in an average case, you may need to do n by 2 visits, but in the worst case, for instance, if you do not have the element in your list, you may need to go all the way end to the list. Or if the element is at the end of the list, then you have to go all the way end visit. This is why it's called the complexity of big O of searching algorithm is big O(n). This big O means that how much time you will need in order to execute this operation. It's all complexity. So efficiency of all algorithms are measured by this complexity. Time complexity is meant. So its big O(n) means it will take maximum n iteration. It's not bad. Okay. I will revisit why I said not bad. Okay. So let us go to this is the algorithm for linear search algorithm. It's pretty simple. Okay. I will show you with a live code. Maybe not to this class, next class. Okay. There is another popular algorithm. It's called binary search algorithm. Binary search, bi means 2, right? by means 2. So binary search algorithm, what it does, every time it divides the list into two halves. Okay. So the complexity of the binary search algorithm is log n, is base 2 log n. Okay. But there is a limitation of binary search algorithm, is that your list must be a sorted list. If you know ahead of time that your list is a sorted list, then you can use binary search algorithm. Okay. So here in the binary search algorithm, the complexity is big O n. Okay, big O log n. That means every time it will be your list will be half. Okay. For instance, if you have an array of 1,000 if you have an array of maybe 1,000 the reason of it's not responding. If you have a list of 1,024 elements, then it will, in the first iteration, after first iteration, it will make it half, 522 elements. Okay, then another iteration, it will make half, 256 elements, and then another iteration, it will make even half, 128, and then another iteration, it will go 64. Like this way, it will need only 10 iteration, only 10 search in order to do this. Yeah.
What is it more efficient to use a binary search architecture? Like, is there like
okay, that yes, it, as I mentioned, the efficiency depends on your list type. If you know that your list is a sorted list, then definitely your binary search algorithm is the most efficient algorithm. But if you know that if you are not sure that your elements are in a sorted list, then definitely you cannot use binary search. Then you have to go selection sort. Okay. Any question?
So, I mean, like, if the list is sorted, when is it more efficient to use?
What is?
If your list of elements is sorted, like in order, when is it more efficient? Like, how many elements would it become more efficient to use?
I will go through an example with the binary searching algorithm. For instance, if we have this list, okay, so how many elements did you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 elements, right? So the elements are in sorted list. So then it will have, in a binary search algorithm, we need a lower value and then higher value. That means we get this lower value by measuring its index. Lower index is 0 and upper index is length minus 1. So we get the lower index and upper index, and then by from the upper index and lower index, higher index, we can get the middle index. So we get the middle index. When we get the middle index, then we can find the middle element. So if our expected value, for instance, 20, we are expecting to search whether 20 is available on this list. So we will get the middle index value at the middle index. Okay, then we will compare that element, here is 35, with my 20. Expected element 20, right? So since I see that 20 is less than 35, so we will truncate the higher part. We don't need the higher part. So we are first sure that our element is on the left side of 35. So we will move my higher index from the last here to from the last element here to here. So you see that array size becomes half. After that, again we will see, again we will find the middle index here, middle element. See, the middle element will be 15. So then we will compare 20 with 15. Then if we see that 20 is greater than 15, so we are sure that our element is not in left side of 15. So we will truncate this left side. Then we will have only these two elements. And after this iteration, we will get our element. If it is available or if it is not available, then we can say that it's not found. So this is the efficient algorithm. But if you would use a linear search algorithm, you have to go all the elements, like first test, pick up 4 and then test with whether it is 20. You say no, then you have to go all the element one by one by one. Okay. So there is another example on this slide. Please go through this slide, and there is a binary search algorithm. How to find, here is one thing, how to find the middle index. Just add the lower index plus higher index and divide by 2, and you will get an integer type middle index. And if you know an index value of an array, then you can retrieve the element from the array by using, you see that here is G is the array, so G of middle, that it will retrieve the middle element. So this is pretty straightforward algorithm we covered in 1321 course. Anyone need help to go through this? Okay. So there is another, I have added this slide. If you go through that, you see that it says base case, base is 1, then average is log, big O log n, and then worst case is log n. So in all case, in the worst case, the efficiency or complexity of the binary search algorithm is big O n. And it says big O1, that means constant. That you may be lucky to find your element at the first search, right? So in that case, it maybe says big O1, that means constant time. Okay, this is the code snippet for a binary search algorithm in Java, and this is in C#. I have my live code. Actually, these are the code snippet. It will not run. You have to put this code in a complete method, main method, right? But I will show you how to. I have my program in our next class. We will go through. So this is the Python code, and then let's go through sorting algorithms. So one of the efficient or most commonly used sorting algorithm is it's called bubble sort. I will tell you in a second why do we say it's a bubble sort algorithm. Okay, and then a bubble sort algorithm actually repeatedly it examines the elements pairwise. Okay, I will show you. Okay. Actually, there are two versions of bubble sort algorithms. Okay, then I will show you both versions. Here is the version A. I say version A. Okay, so that means I usually tell it version A. I said version A. Okay, please. I will tell you why do I say version A. Okay, there is a logic. Okay, so in A, so we see that how to write a capital A. So we have, like, if we give a circle, then the top circle will be smaller, and then or oval, or what is called bubble, ring. If we put ring through this A, so then the latest or the bottom circle or oval will be larger, right? And the top one will be smaller. So that the logic is that we will use bubble. Okay, like bubble means usually we draw just the edges of a bubble, and we will compare the ending values, not value inside the bubble. Okay, really, actually, a bubble is, why is that working? Give me a second. It's not responding to me. I want to open my paint over here. Sorry, it's not responding. It's completely slow. Okay. So first of all, I will start with a smaller bubble. Okay, and much more smaller ring. So for instance, that will compare 4 and 8. So let us start with this set A, list A. Okay, then it has 4, 8, 2, 1. We want to sort it, display it in an ascending order. Ascending order means the lowest element will come first, then the next lowest, or the bigger one, then bigger one, and the largest or the biggest element will go all the way end. Okay, so then we will compare 8 and 4. Okay, since 8 is greater than 4, so there will be nothing. Okay, no exchange. Okay, and okay. Oh, sorry. We will start from here. We will compare 8 and 4. Since 4 is less than 8, so we will be swapping 4 and 8. Between 4 and, so 4 will come here and 8 will go there. So, and this is not the end of the first iteration yet. So then again it will make the bubble larger. Then we will compare 2 and 4. Okay, sorry. So then it will compare these 4 and 2. These 4 and 2. Right? These 4 and 2. Since this 2 is less than 4, so then 4 and 2 will be swapped. So then it will come 2 here and 4 over there. Okay, then it will make the bubble A larger. So it will compare 2 and 1. So 1 will come here and then 2 will go there. So at the end of first iteration, we will get 1, 8, 4, 2. Then we will get 1 sorted and in position. And in the next iteration, we will start from this part, because we know already that 1 is in place. So then again we will start with a smaller bubble. Then we will compare with 4, 8 and 4. Since 4 is less than 8, so 4 will come here and 8 will go there. And then again we will make the bubble larger. So then 4 and 2 will be compared, and 2 will come here, and 4 will go there. So after, at the end of iteration, it will get 2 elements sorted. And in the third iteration, we will compare 8 and 4. Since 4 is less than 8, so we will get, okay, so 4 here and then 8. So we will get our list sorted. Okay. Anyone has any question about this? So this is the version A. That means we will start from a smaller bubble, and we will make the bubble larger. Okay. So this is the concept. But we will always remember that we will check only the values at the edges of the bubble, not any value inside the bubble or outside the bubble. For here, when we have a bubble here 2 and 4, we will not consider 8. We will just consider 2 and 4. Okay. So as I told you, there are two versions of the bubble sort algorithm. So version A, it will start with a smaller bubble, and it will go to the larger bubble. Okay. And version B, so as I discussed version B A earlier. So in version B, like version B, so you will have the same bubble. You see, in B, when you type in B, there are two bubbles here, all of the same size. So remember that way. For instance, what was our data set here? Anybody can remember? 8, 4, 2, 1, right? Our data set was 8, 4, 2, 1. So we will compare first 8 and 4. So we are discussing here version B, not A. So since 4 is less than 8, so this will be extends. So 4 will come here and 8 will go there. Okay. And now we will shift or move our bubble to the right. So then we will compare. We have this set, so we will make the bubble again here. We are making the same bubble size, okay? We are not making the larger bubble, remember, in version 2. So then we will compare 2 and 8. So 2 will come here, 8 will go there, and 1 we do have here. So then we will do another bubble here, and we will compare 1 and 8. So 1 will come here, 8 will go there. So at the end of first iteration in version B, we will get 4, 2, 1, 8. So nothing is sorted yet, right? 4, 2, 1, 8. Nothing is sorted yet. This is the end of the first iteration. Okay, then, oh, sorry. Actually, we got one sorted element. Okay, sorry. So at the end of the first iteration, we will have 4, 2, 1, 8. That means we have one value in place. That is the last element. We have one value in place. That will be our last element. So at the end of one iteration, first iteration, we will have 4, 2, 1, 8, and we will have our one element sorted in position. That is the last element. Is the difference between this and previous version? Okay, then what do we need to do? We need to go until this part, right? In previous version, we are moving to the next element, but we are moving this from right to left. So then this time we will compare 4 to 1. We have 8 in place, so we do not do anything with 8. So then we will do again 4 and 2 compare. Then we will get 2 here and 4 here, 1 in place. And then we will make the same size bubble, and we will do 1 here and 4 there, and then 4 will be in place. Okay, sorted. Then at the end of second iteration we will get 2, 1, 4, 8, and actually we will get 2 elements sorted. These are the
algorithm here on the PowerPoint.
Is
version B or version A. Okay.
The algorithm here is that this is the second version B. Okay, this is the second version, and we need one more iteration. Okay, so we have already we need. So we got, what are the values we got? Remember anybody? We got 2, 1, 4, 8, right? So we got 2, 1, 4, 8. So we have in version B. We are talking version B. So we got 2, 1, 4, 8. 4 and 8 are in place, right? So then we will need one more iteration. We will compare 2 and 1, right? Since 2 is greater than 1, so 2 will go here and 1 will come here. So then we will get this element in place, and we already have 4 and 8 in place, so we will get 3 elements in place. So at this time we will see that our array size is 1, list size is 1, so then we are done. Okay, so the difference between version A, version B, A version versus version A is that in version A you will make in version A you will make your bubble larger and larger. You will start from a smallest bubble, and you will make your bubble larger and larger and larger. But in version B you will keep the version size, bubble size same. You understand the difference? So if you do a Google search, you will see that both versions, there are programs in both versions. But people maybe sometimes do not say that this is this version or that version. I do remember this way, because in A, when I type in A, it has A. When I write in A, so I remember this way. When I was a student like you, I remember that way. So this A is smaller, and then this is larger. And B, just you have a B here. So in B you have 2. If you write a good B, so if you draw a good B, so then in B you have 2 same bubbles, right? So remember that in version B you need to keep your bubble same size. Okay, yes, what is your question? I don't know, people name it version A or version B. This is my naming convention. This is the way I remember. Okay. So this is my way to get a lifelong learning. When I found this way to remember, I never forget. Okay, I think if you remember it, then I believe you will not forget about it. So in our PowerPoint slide, we do have version what? A. Okay, so follow this version unless you see. But remember that there are 2 versions. I believe when you take your data structure and algorithm class, then you will learn more. When you do more work, then definitely you will face. Anyone has any question? So his question was, what is your name, please? Aryan. Okay, his question is that is there any name A or B? If you do Google search on in a book, I think I don't know that you can get a version A or version B. I saw that people even do not say this is the there are two different versions of bubble sort. Even people do not say. So everybody clear about bubble sort? Okay, I'm lucky that you got it in in one sort. Okay, so this is the algorithm of bubble sort. So you see that for each j from 1 to n, we are increasing j. That j means the next smaller bubble. So that means we are using the first version A. Okay, this is C# and this is Java code. So please go through this. This is for Python, and there is another algorithm for selection sort algorithm. Okay, so in selection sort algorithm, you will find if you want to, for instance, if you want to do an ascending order, so then you will go through all of the elements. Okay, and you will get the smallest element, and then you will put the smallest element in the first place. Okay, then you will get the second smallest, and then put next place. There is this is the working procedures. So this is an algorithm. Okay, maybe we are out of time almost, right? So I like you to go through these algorithms. So and these slides. Okay, so before in our next class we will go through this, and there is this is the comparison between bubble sort and selection sort. When do you use bubble sort and when do you use selection sort? Okay. In general, if anyone asks me to do a sorting algorithm, I usually do a bubble sort algorithm in the version A, making the bubble larger and larger. And there is another and there is another algorithm. Give me 1 more minute, please. Insertion sort. We did not cover this in our last course, 1321, but we will cover this in this course. Okay, insertion sort algorithm. Okay. I don't have time today. Okay, next class we will go through, but please, this is your homework. Okay, please go through this slide and learn about insertion sort algorithm. Okay, this is your homework for the next class. Okay, so please come here with some study and practice with insertion sort algorithm. Okay. And that's it for now, and then I will see you in next class. Thank you so much.
For this,
Okay.
this case.